Hello and welcome to update of my custom engine, where I'm going to talk about recent collision and memory changes. In this video, we'll go through what is new and do a little peek into how it was done. First addition is support for capsule shape collision. The capsule is defined by height and radius. Collision detection checks first a possible collision with circle along x and z axis, then checks collision with body along y axis, and then calculates collision as sphere if collision happens to be occurring at the edges of the capsule. This capsule collision detection is quite simple, but in the future it would be nice to change it to support various orientations. Besides adding capsule, I have also fixed boxes to have correct collision at the corners. Previously, objects were overlapping with the corners of the box as if box would be actually rounded. There was also issue with collisions for boxes that were not an exact cube, which is now fixed as well. So currently engine has collision shapes for sphere, box and capsule. These are pretty much all the shapes I will need for starting a simple game, using spheres for rounded objects or effect areas, boxes for triggers or walls, and capsules for characters. Some possible additions might be a plane or arbitrary shape, but that is likely a topic for later. Physical interactions are currently very simple. Bodies of all shapes can detect if they entered or left the other bodies, and solid shapes will push each other to prevent overlapping. Currently, our existing pairs of shapes are tested between each other for collisions using a specific algorithm for a specific shape pair, for example, capsule to box, box to box, and so on. There's definitely a lot more for improvement, like having more detailed physics behavior, collision algorithm optimizations, or limiting how many body pairs are tested for collisions. But overall, current functionality is sufficient for now, so rest will get improved as needed. Engine now can also detect closest collision with ray, well, actually a line segment with given start and end point, and this works for all available shapes. With that, it provides info about collision point, position and normal. This can be typically used to detect if player shot a target or is looking at interactable objects, so that is something I definitely wanted in Fika engine. Raycasting is done in frame. Therefore, raycast needs to be called every frame if one needs to have continuous detection. In addition to raycasting, there are two smaller features, which are lines drawing and collision layers. Line drawing, similar to raycast, is being done in single frame and then it's thrown away. This can be used to visualize arrays or connections in 3D space. It is probably not the best thing to do an arbitrary shapes with it, but it works well for its purpose and it can be expanded. Collision layers are done using bitmask. Each body has bitmask to set which layer it does belong to, and second bitmask to set with what layers it can interact with. In current test case, I have set player and box to be at different layers. Ray coming from the player interacts only with the box layer and ignores the player layer. Therefore, ray won't be detecting player as a collision. Thanks to layer setting being a bitmask, body can belong and interact with multiple layers at the same time. Layers implementation is done quick and dirty, so this will definitely need more work to be more easy to use. At the beginning of the project, I got pool allocator to be able to reserve space for X amount of variables of any data type, but I did not really use it as there were some issues. For a majority of lists, I was using a vector of object pointers to store, for example, collision shapes, physics bodies and such. This was working okay, but it took so much time to spawn new objects into the game as new memory had to be allocated for each object. With pool, I can reserve space for X amount of object and this space is never changed. Every time I need new object, I just fill the data of existing dummy object in the memory. Also, if more objects are needed than is the pool size, the pool will automatically allocate space for another pool without affecting already used data. But be aware that getting data from additional pools can be slower, as the additional pools are accessed using recursion. Therefore, there is a little warning every time that there is a need to extend the pool, so user is aware that more space is required. Also expecting that using pools for physics objects will result in more FPS, as data should be nicely packed together and not scattered around the memory. So far I haven't noticed a significant boost in performance, but this change has lowered the time needed for creation of new object. Simple test creating 500 physics bodies on starting the engine went from waiting for around a minute to start pretty much instantly. At this point I haven't done any rigorous benchmarking, but impact on creating the object is obvious. Besides that, custom pools allocators give me an option to customize its behavior or have custom debug info. That has been all from recent changes. Next on my list is to look into creating a scene graph or some way how to parent object transformations. With that, I would like to touch serialization of prefabs and levels and maybe start playing around with some basic editor. This all might take some time, but I'm sure it will elevate Fika to feel a little more like a proper engine. I'll be looking forward to share more of my progress next time. Don't forget to click subscribe if you are interested in more updates, and I will be happy if you would leave a like or comment with any questions or suggestions. Wish you a great day and see you at my next update.